Hi, today we're going to solve a splendid equation and we're going to make a lot of clever algebraic moves along the way. So what we want to do is find a triplet of rational numbers, a, b, and c, such that the cube root of 2 minus 1 equals the cube root of a plus the cube root of b plus the cube root of c. Okay, so let's check this problem out. The first move we'll make is to call this quantity here, the cube root of 2, x. We can cube both sides, and what that gives us is x cubed on the left and 2 on the right. But now there's two things we can do with this. First of all, we can add 1 to both sides, so we get x cubed plus 1 equals 2 plus 1, or 3. But that just gives us a sum of cubes on the left-hand side, so we can factor that. So it factors as x plus 1 times x squared minus x plus 1. That's the left-hand side, equals 3. But what we can also say, or do, is break up this 2 over here as 1 plus 1. By doing that, we can take one of these ones and subtract it over here on the left, so we get x cubed minus 1 equals 1. But now we just have a difference of cubes here on the left-hand side, so that can factor as well. So we get x minus 1 times x squared plus x plus 1 equals 1. Okay, perfect. But next, what we can do is take this quantity right here and rewrite it as such. We'll multiply everything by 3 and then divide by 3. But from a, we know that 3 is just x cubed plus 1. But if we shuffle some things around there in the numerator, we can write x cubed plus 3x squared plus 3x plus 1 all divided by 3. But this reminds us of Pascal's triangle, the coefficients 1, 3, 3, 1 with decreasing powers of x. So that just factors as x plus 1 all cubed. Okay, great. So we'll put that on hold right now. And the next thing we'll do is let this entire quantity now be y. What we can do then is cube both sides. To obtain that, but we recall from what we have in white that the cube root of 2 is just x. So we can write y cubed equals x minus 1. But notice there's another x minus 1 hiding here, right up here in pink. So why don't we go back here for a moment and write the following. X minus 1 equals 1 divided by x squared plus x plus 1. So that now tells us that down here in green, y cubed is nothing more than what we have in pink, x minus 1. But remember, x squared plus x plus 1 is what we have in brown. And that's just x plus 1 all cubed divided by 3. So now we can write that y cubed equals 1 divided by x plus 1 all cubed divided by 3. But dividing by 3 just brings that 3 upstairs. Okay, great. So this now tells us that y is nothing but, well, let's cube root both sides, of course. So y equals the cube root of 3, all divided by x plus 1. But notice where else we have an x plus 1, up here in blue. So what we'll do in blue then is write the following. We'll divide the 3 over here on the left and divide the x plus 1 over on the right. We have a 1 left up here and x plus 1. So now we can sub in our blue 1 over x plus 1 over here. Now, of course, what we have here is nothing more than the cube root of 3 times 1 over x plus 1. So this means that y is the cube root of 3 times what we have in blue. X squared minus x plus 1 all divided by 3. But recall, what did we call x? X is up here in white, the cube root of 2. So now y is the cube root of 3 divided by 3. We can just shift this under here. Times x squared, so the cube root of 2 squared, minus the cube root of 2 plus 1. But this quantity over here is just 2 to the power of a third all squared. And that's 2 to the power of 2/3. So that's like writing 2 squared to the power of a third, which is just 4 to the power of a third, or the cube root of 4. So now we can say that y is the cube root of 3 divided by 3. Well, that's just 3 to the power of a third divided by 3 to the power of 1. But we can write that as 3 to the power of a third minus 1, which is 3 to the power of negative 2/3. And then we have what remains in brackets, the cube root of 4 minus the cube root of 2 plus 1. But this is nothing more than 1 over 3 to the power of 2/3. And that's the same thing as 1 over 3 squared to the power of a third, or in other words, 1 over the cube root of 9. So y equals 1 over the cube root of 9 times the cube root of 4 minus the cube root of 2 plus 1. And so ultimately, if we distribute this into the bracket, we have the cube root of 4 divided by the cube root of 9. That's just the cube root of 4/9. And then here we have the cube root of 2 divided by the cube root of 9. That's just the cube root of 2/9. And then we have this right over here, which is the same as 1 over the cube root of 9 However, we can imagine that this 1 is 1 to the power of a third divided by 9 to the power of a third. So this is just the same thing as the cube root of 1/9. But of course, y was nothing more than this, the left-hand side of our equation. So the cube root of 2 minus 1 equals the cube root of 4/9. And 4/9 is our a, minus the cube root of 2/9, and 2/9 is our b, plus the cube root of 1/9, and 1/9 is our c. Of course, we can always pull in a -1 into this radical, so we get the following. So we can conclude that our triplet of rational numbers, a, b, c, is nothing more than 4/9, -2/9, and 1/9. I hope you enjoyed that. Thanks for watching.